With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
In this question, fx is given as mod of x, gx is given as sin x, and hx is given as gx into f of gx. Then we need to check continuity and differentiability at x is equal to 0 of hx. So first of all, we have fx is equal to mod of x, gx is equal to sin of x, and we have hx is equal to gx into f of gx. Substituting the value of gx here, we'll get sin x into f of sin x. Now input of any function in fx, input of f would become, f will give output as sin x into mod of sin x. This is hx. So now we know the property of mod function, that mod of x is positive x if x is greater than or equal to 0 and negative x if x is less than 0. Since we have sin x is always positive for x belonging to 0 to pi by 2, and sin x is negative for x belonging to minus pi by 2 to 0. We are checking this in the interval minus pi by 2 to pi by 2. So using these properties, we can write hx, which is equal to sin x into mod of sin x, is equal to, so for x greater than or equal to 0 and less than pi by 2, this bracket will open positively, so we'll have sin x into sin x, that is sin square x. And for x less than 0 but greater than or equal to minus pi by 2, this bracket will open negatively, so we'll have minus of sin square x. So now this is the new definition of hx. Now let us check the continuity and differentiability according to this definition. So let us check at x is equal to 0 continuity. First of all, we are checking continuity. So left hand limit, that is limit x tending to 0 negative hx, would be equal to, for x less than 0 it is equal to minus sin square x, that would be equal to limit x tending to 0 negative minus of sin square x. Now if we substitute x is equal to 0, we'll have minus of sin square 0, sin 0 is always 0, so it would be equal to 0. Now let us check right hand limit, 0 positive hx, that would be equal to limit x tending to 0 positive, here it is minus, and for this x tending to 0 positive, since for x greater than or equal to 0, we have sin square x, fx is equal to sin square x, so sin square x will be there. If we substitute x is equal to 0, we'll have sin square 0, that is equal to 0, and h of 0 is also equal to sin square 0, that is 0. So we can say, since this and this all three are equal, which is equal to 0, so we can say hx is continuous everywhere. If at x is equal to 0 it is continuous everywhere. Now we need to find its derivative. So we have hx, more or let us assume another function f, capital F, equals to sin square x in order to find the derivative of this. So if fx is equal to sin square x, first of all, differentiating with respect to x, we have df by dx is equal to, differentiation of any function is equal to, first of all this will become 2s of sin x into d by dx of sin x. So d by dx of sin x is, differentiation of sin x with respect to x is cos x. Now we know 2 sin theta cos theta is equal to sin 2 theta. So df by dx derivative is equal to 2 sin x cos x would become sin 2x. So we have hx, h dash x equals to positive sin 2x for x greater than or equal to 0 and less than pi by 2, and negative of sin 2x for x greater than or equal to minus pi by 2 but less than 0. Now we need to check its differentiability. Again we are checking at x is equal to 0. So now first of all checking left hand, so x tending to 0 negative, h dash x that would be equal to, for x tending to 0 negative, it is equal to minus sine 2x. So limit x tending to 0 negative minus of sine 2x. If we substitute x is equal to 0 here, minus of sine 2 into 0. So this would be equal to sine 2 into 0 would be sine 0. So limit x tending to 0 negative h dash x is equal to 0. Now we are going to check right hand limit. So now, since we have a left hand limit equals to 0, right hand limit would be equal to limit x tending to 0 positive h dash x, and for x greater than 0, h dash x is equal to sine of 2x positive. So if we substitute x is equal to 0, this will again be 0. Now we can see that left hand derivative and right hand derivative are equal. This implies we can write hx is differentiable at x is equal to 0. This implies hx is differentiable everywhere. Differentiable everywhere. Because there is only one critical point at x is equal to 0, and at that point, if it's satisfying the condition for differentiability, it is differentiable everywhere. Hence, the correct, if we have to mark the correct option is hx is continuous and differentiable at x is continuous and differentiable at x is equal to 0. This is the only correct option.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.